everyone. Today we gather to conduct a thorough continuous group case study discussion regarding Thomson Telescopes Ltd Berhad. Through collaboration, we can combine our ideas to analyze this operational issue from both a quantitative data standpoint and a qualitative strategic perspective. To provide the initial context of the case, Thomson Telescopes originally began its journey strictly operating as a sales division for US manufactured telescope units. However, to capture local European market demand, better accommodate specialized custom client configuration and significantly slash shipping lead times, they transitioned into a direct manufacturing setup local in Vale, South Wales. But despite achieving some very promising initial expansion, their performance has recently hitting a brick wall. Sales have stagnated, net corporate profits have entered a severe decline, and the volume of customer complaints regarding late product deliveries has risen dramatically. Arisa, as we begin our analysis, could you guide us through the primary day-to-day operational issues that are causing this performance breakdown?
Thank you so much, Kopo. When we dive into the core operational issues highlighted in our report, the most fundamental day-to-day problems stem from a severe structural mismatch between the sales team and the manufacturing plant. To put it simply, the sales forecasts generated by the firm are completely unreliable and highly inaccurate. Despite having no real-time insight into the factory active capacity, the sales force regularly drop last-minute orders directly onto the production floor. Because the sales department operates in complete isolation, they continuously quote totally unrealistic delivery schedule to clients just to close deals. This behavior has made late deliveries the standard rule rather than the exception. It creates an incredibly wasteful loop where salesmen must spend their working hours physically chasing orders through the production line, and in some cases even driving out to personally deliver telescope to angry customers. Renika, how does this sale pressure disrupt the planning behavior on the shop floor?
After listening to your point, I think it supports the capacity analysis and show why the plant's internal planning has completely crumbled under pressure. This is because supervisors are desperate to maintain local level productivity percentage on paper, they make very poor operational trade-offs. Whenever assembly kits are short of parts, supervisors choose to independently divide standard production runs into highly fragmented part batches, or they push random jobs ahead in the schedule without any proper authorization. The worst part of this operational breakdown is that these emergency components regularly leave the storage stockrooms without a single piece of tracking paperwork or system logging. This completely jumps out the master production schedule. Rizka, what happened to our data integrity and warehouse visibility when components are moving around without paperwork?
The result is absolute data chaos, Renika. Because parts are constantly taken from the shelf without system registrations, the accuracy of Thomson stock records has plummeted to a catastrophic 50%. Because physical inventory audits are only conducted twice a year. These massive discrepancies are left completely uninvestigated. This leaves Thomson's inventory system severely stranded. They are trapped in a terrible position. They are heavily overstocked on low priority items. Yet they are regularly run nil stock on critical components, forcing the entire assembly line to freeze. Stephanie, how do the engineering, design, and supply them add to this problem?
I respect your perspective on the forecasting model and the stock research Rizka. The lack of warehouse control is astonishing. They operate a highly lax requisition system where completely unauthorized staff can walk in and take part, and salesmen actively pillage the warehouse to find missing part for their late orders. Top On top of that, rigid supply chains, constraint, and non-standardized engineering design completely strangle their agility. Ordering parts from their US affiliate come with an inflexible 4 months lead times, meaning they cannot react to sudden shift in the European market. To make matters worse, engineering used to completely incompatible part number system and non-standardized part. This has cluttered their active components catalog across more than 200 different telescope models, creating massive and unnecessary operational complexity.
Thank you for outlining those critical issues. Let's transition directly into our quantitative analysis so we can walk our lecturer through the exact mathematics of our report. Our group conducted an ABC inventory analysis on a representative sample of 35 component parts out of Thomson's 2,500 total active items. The aggregate annual expenditure calculated for this entire 35 item sample group is exactly 56,889 pounds. Since we want to explain this clearly in text sentences without relying on a table, let's detail the mathematical steps we use. First, we calculated the annual expenditure for each item by multiplying its annual unit usage by its individual unit cost. Second, we ranked all 35 components in descending order, from the highest annual expenditure to the absolute lowest. Third, we divided the ranked items into classes A, B, and C based on the Pareto principle, which states that a small percentage of items represents the vast majority of financial value. Rizka, could you explain how the data look for our high-value class A items?
Yes, Koko. When we look at the high value class A segment, our calculation showed that it contains just 4 specific parts of the 35 sample, which represent only 11.4% of the total physical items. However, from a financial standpoint, these 4 items consume an overwhelming 60.4% of Thomson's total annual spend, which equals to 34,369 pounds. A highly critical finding that we must point out is item A024, which is an outsourced component from the US affiliate. This single component drives a massive annual expenditure of 13,226 pounds. This means that item A024 alone accounts for a staggering 23.2% of the entire 35 item sample budget. This shows us that tight, continuous financial control and daily stock monitoring must be applied to this class to prevent production halts. Alisa, how did our calculation turn out from the class B tire?
I'd like to provide some constructive feedback on that solution and expand on the intermediate class B tier data. Our analysis showed that class B comprises 8 items out of the sample, which calculates to exactly 22.9% of the total physical items. Financially, these 8 items account for 29.6% of the total annual impact with a value 1682 pounds. The items in this tier include specific parts like E035, F014, and A031. What our data analysis exposes here is a massive financial inefficiency in how stock values relate to usage. For example, look at class B item E035. Thomson has an incredible 5,854 pound completely tied up in on-hand physical stock values for this part, but its actual annual usage is only 3,902 pound. They have looked up money in physical inventory volume that significantly exceed what the factory consumed in a year. Radhika, how does the data look for our final tier class C?
The class C tier data provides clear mathematical proof of pool management. Class C encompasses the vast of physical items containing 23 out of the 35 components, which is a massive 65.7% of physical volume. Yet, when we calculate their financial weight, they represent a minor 10% of the annual expenditure, totaling only 5,688 pounds. These brackets contain parts like B028, D044, B025, and B010. Because Thomson uses a uniform unappalated inventory rule, they are over-purchasing these cheap parts massively. For instance, the cheap components B028 and D044 carry heavy physical stock values of 2,656 pounds and 1,878 pounds respectively. But when we check their actual annual usage values, Thomson only consumed 1,622 pounds and 670 pounds worth of those parts in a year. They are holding low value parts that collect dust while running out of high value parts.
Exactly, Veronica. This quantitative analysis provides absolute proof that Thomson inventory value are completely disconnected from actual manufacturing usage. By maintaining identical, outdated stock control metrics across all parts, regardless of whether they cost pennies or hundreds of pounds, they are heavily driving up their 20% annual holding costs while completely failing to protect product availability.
Now that we have explained the exact mathematics of our report, let's discuss the qualitative impacts this has on the company's performance. Specifically, let's focus on manufacturing efficiency, holding costs, delivery reliability, and customer satisfaction. Renisa, how does a 40% record accuracy affect daily life on the factory floor?
It completely destroys daily manufacturing efficiency. When you operate with a stock record accuracy of only 48%, you are essentially flying blind. Assembly operator opens up kits only to realize crucial components are missing, resulting in massive production delays. To hit urgent target or placate streaming salesmen, shop floor supervisor have to constantly speed measures or delay schedules. Every single time you split a batch or stop a run, you force a machine reset. This skyrockets setup times, plummets capacity utilization, and completely breaks the master production schedule. The end result are longer manufacturing lead times, degraded labor productivity, and massively inflated operational running costs. Stephanie, how does this translate financially regarding holding costs?
The financial numbers are incredibly damaging in Veronica. In 2001, Thomson total inventory reached a massive 2.794 pounds millions because they are storing mountains of unbalanced, overstock, low priority item and paying a hefty 20% annual carrying charge. They are literally bleeding approximately 558,800 pounds every single year just in holding costs. This massive amount of wasted money completely ties up their working capitals, storage and handling fees, and drag their return on capital employee or ROCE far below their corporate target of 15%. They are drowning in inventory, yet they don't have the part they actually need to building telescope. Alisa, what does this do to delivery performance?
It ruins it completely. Thomson promises customers a standard 2-week turnaround time for customized telescope. But because they regularly run out of critical Class A components, they miss this window completely. And remember, when they run out of a critical Class A item that is outsourced from their US affiliate, they can just source it locally. They have to wait out a rigid 4-month shipping and production lead time from America. This completely shatters their delivery reliability, stretching customer wait times from weeks into months. Riska, what is the ultimate consequences of this at the customer end?
Okay, serious, escalating customer dissatisfactions. Customer complaints are rising and the market is rapidly losing confidence in Thomson's ability to perform. The sales staff are stuck in a highly counterproductive loop. Instead of driving new sales or exploring new European market segments, they have to spend their entire working days chasing down land orders on the factory floor, dealing with angry clients and forcing urgent last-minute requests into an already broken production line. If these structural deficiencies persist, Thomson will face total loss of market share to more operationally agile telescope competitors.
This brings our discussion to a critical turning point. What must Thomson telescopes do to resolve this crisis? In our report, we evaluated and put forward two major operational recommendations: the implementation of an ABC-based inventory control system and the deployment of a material requirements planning or MRP system. Let's critically evaluate these alternatives. Arisa, how will transitioning to an ABC control framework fix the warehouse?
An ABC-based inventory control system will completely replace Thomson flow, uniform stocking rules with structure, value-driven segmentation. By classifying their 2,500 active products into categories based on annual consumption value, management can allocate their focus appropriately. Class A items, which represent the highest value and financial risk, will receive strict, continuous review, tag monitoring, and highly frequent cycle counts. This ensures that Thomson stop over-ordering expensive part blindly, increases stock record accuracy well above 40%, and guarantees that critical components are always available. This system will dramatically lower excess inventory holding costs while simultaneously improving overall manufacturing service levels.
After listening to your point, I think it supports the capacity analysis and inventory balancing goals flawlessly. However, organizing the warehouse via ABC classifications only fix current stock management. We must also fix future production planning. This is why our second recommendation is the immediate implementation of a material requirements planning or MRP system. An MRP system uses demand forecast, stock records, and bills of materials to calculate exactly what components are needed, in what quantities, and exactly when they must be released to production. This completely eliminates the long manufacturing lead time of 3 to 12 weeks and stops supervisor from making unauthorized schedule changes.
I agree completely, Rista. The MRP system serves as a data-driven bridge between sales and manufacturing. Instead of sales personnel blindly promising unrealistic delivery dates to client without consulting factory capacity, the MRP system provides transparent, real-time availability schedule. To maximize this effectiveness, we also recommend establishing mandatory, regular cross-department coordination meeting between the sales, engineering, and manufacturing teams. This open line of communications allows for realistic delivery commitments, stabilize the master production schedule, and eliminates the disruptive last-minute flow order that derail daily productivity.
This is an excellent comprehensive evaluation, guys. To run out our case study analysis, let's briefly look at the sustainability and responsible operations aspect of our recommendations. Mapping back to our ESG4 criteria. Stephanie, how do ABC inventory control and MRP alignment support sustainable operation management?
Through collaboration, we can combine our idea to analyze this operational issue from a long-term, responsible research lens. Moving away from the chaotic, blind inventory system directly improve efficient resource utilization across the entire EBBW field plans. By utilizing ABC value, constraints, and MRP time pass planning, Thomson will drastically reduce excess inventory level and completely eliminate material waste caused by components obsolescence. Storing fewer unnecessary parts mean a smaller warehouse footprints, lower energy consumption for storage facilities, and highly streamlined and lean production flow. This is the very definition of sustainable operation management and maximizing output while heavily minimizing operational waste.
Beautifully stated, Stephanie. Our quantitative data and qualitative analysis have shown a very clear path forward. Can we officially come together and form a team consensus on these recommendations?
Yes, absolutely. These two synchronized solutions perfectly address both the material control flows and the departmental communication gaps.
I fully agree. They directly eliminate the structural issue highlighted in the case study.
Based on our discussion, we have reached consensus on the best operational solution for Thomson telescope.
Wonderful. To conclude our group discussion, our analysis proves that Thomson telescope's failure are not due to market conditions, but due to severe internal operational misalignments. By deploying type ABC continuous review for high-value items and integrating an MRP framework supported by cross-functional coordination meetings, the company can easily restore its stock record accuracy, eliminate its massive 5,800 pounds annual carrying waste, and re-establish the delivery reliability needed to capture the European telescope market. Thank you to my brilliant team members for an exceptional collaborative effort, and thank you for your time.